In this next exercise in Excel, we'll consider the payment function. And to make this more meaningful, um, let's I'll include a story that I heard from a student of mine. He was a freshman. He had a car. It was an older car, just learned to drive, and he wanted to put in a stereo. And he had saved up some money through the summer. He had a job, so he went to one of the local stereo install shops, and he brought in about $700, but soon learned from the salesman that he would be much happier with a $1,700 stereo. But wait, he talked to the finance manager and he had some good news. He could make payments. His interest rate would be 19%, but not to worry, the payments would only be $25 a month, or less than 30. So let's see what this stereo really cost the student. So we'll start out by labeling some of our fields. The first is the price of this stereo. We'll label it, and in the adjacent field we'll put the value, and I think the total cost, including tax, to make things simpler, was $1,700. Then we'll skip a couple fields and we'll put in the interest rate. And the interest rate was yearly, so I'll put a YR. There we are. And there's going to be a number of payments. There we are. And the actual payment itself. Okay, I think that's what makes up of a loan. For the interest rate, annual interest rate, well, in Excel we should set that to interest, or rather to percentage first. We could put the percent symbol after the 19, but I like to set it ahead of time so that when I type it, it's really 19%. Now it turns out that since these are monthly payments, the interest rate at 19% is not going to happen every month. So we need to take that 19 and divide it by the number of months in the year. So we'll use the equal sign to start our formula and click on our arrow up to where the percentage is typed in and divide that by 12 for the months of the year. And we'll set that as percent as well. So it's not, oh wait a second, that number changed. Well, I thought it was something different than 2%. Well, it turns out it is. It's just that we don't see enough of those decimals to recognize what it really is. So let's bring it out to about the fourth decimal or so. Now the number of payments is unknown, and we're not going to use some of the advanced tools to determine that. We'll actually type in different numbers to get close to that, at least at this stage. But we are ready for a payment function. So I will type in equals and then the letter P, and then choices come up. And as I look at those choices, I see one that I recognize, PMT. I'll type the letter P, and I see there's payments, so I'll double click that, and it wants to know, if I click in that cell, we get a little clue here of what numbers go in. So it looks like the rate goes in next. Now if I was concerned about knowing what these values mean, I could click on them and it would tell me, but I know that the rate is interest rate, so I'll just click right on the cell where I've calculated my monthly interest rate, and I'll put a comma in because that's what I can see in the suggestion here for how to use this function. NPER, well, that's also something I recognize, number of payments, so I'll put that there, another comma, and PV. What is PV? I'm guessing that's present value of the loan. Well, the present value right now is the price. I think that's all we have to have, so I'll close this with a parenthesis and press enter. And it says number, which is an error, which means one of the numbers in the formula is not quite right. Well, that's the part where I said earlier we're going to type in numbers to find out what this is. If I made this 300 payments, what would the payment be? Or 300 installments? 27. Oh, that 27 is less than 30. Let's go with that. Oh, but how many years is that? Because usually when they calculate this, they tell you how many years your payments are. I can probably change this formula so that this is a nice round number for years, and if there's 12 months in a year, if I divide that by, it'd be 25 years, no way. So let's change this formula. This is going to now be equal the number of years multiplied by 12, because there are 12 months in the year. Yep, it's 300. Well, hopefully that's not going to be how long it's going to take. So I'll still label this row, and we'll change this. We'll change our years to be 10, 31. Well, we did say it was going to be less than 30, so can we try 15? Let's get it closer. How about 12? Oh, $30.05. So 12 years, $30.05. I think we did it. Our payments are $30 or so for our car. Wow, 12 years. I actually talked to the student and asked him if he planned to drive this car when he went to college, which would be 5-6 years from the time we talked. And he said no, he plans to sell it. I said, well, when you sell your car, you know, the stereo doesn't really add it to its value much. You're going to be paying for 5 years for someone else's stereo. He thought that wasn't fair, and I agree. Let's learn a little bit more about what is happening with this loan. If I wanted to find out what the total payback amount was, total payback, it's going to equal, well, how much we pay times how many times did we pay it. And that looks like $4,000, 326. Wait a second, that's a lot more than the $1,700 that the salesman sold a stereo for. So how much did our loan cost? I mean, the privilege of borrowing money. Total cost of the loan. Isn't that going to equal how much we borrowed? Now, I want you to remember this is a negative number, so there's a little bit of a math logic issue here. I want to find the difference of something, and to find the difference of something we usually subtract, but since this is already a negative number, I'm going to add it to the amount paid back. So the amount paid back is going to be less the $1,700 stereo that we got. So all that's going to be left is what we will be paying out in a loan, and that's $2,600. So for a $1,700 loan, we paid $1,700 plus $2,600. Oh, but wait a second, we forgot part of it. He said he brought $700 with him. So that's considered a down payment. We'll label that down payment. We'll put in the fact that it's $700, and now this is the present value of the loan. So now that's the present value of the loan. I still need to calculate that, so I'll type the equal sign. It's going to be the original price less whatever is a down payment. So I still owe 1,000, 1,019%. But our formula didn't change. Why is that? Well, let's double click this payment function and see why. I see. It turns out that blue 8, that's the interest rate, that hasn't changed. Red, number of payments, that hasn't changed. Purple B4, that changed. I'm going to move this cell by grabbing the border down to where our present value really is and press enter. So our new payment is $17.67. Okay. We need to adjust our other formulas. Total payback, yeah, that still has correct values. And total cost of loan, I'll double click that. And we're still looking at the old price. We need to go down to where the present value of the loan happens to be. I'll press enter. So our amount's a lot better, at least a lot better than it was. But what happens if we actually increase the amount of the payment and not pay it back in 12 years? I mean, who can't handle $17? But still, I'm paying $2,545 for a $1,700 stereo. I hope not. So let's change that to half, 6 years. And our payment went up to $23. And total cost of the loan is a lot more manageable, $683. It still seems to be a third of the original price. So let's bring it right up to 30. If I were to reduce this to 5 years, not quite there yet. How about 4 years? And $29.90. That's close to $30. Okay, so $30, 4 years. I'm still paying $435 more for the loan. What would happen if I doubled my payments? I'm going to press or shorten my time by 2. So I've typed in 2 years. Now the total cost of the loan is $209. So if I paid $50 a month, $209, that'd be a lot more manageable. And what if I paid it in 1 year? It would be $92 a month, but it only charged me $105 more to get that 92. Well, it turns out that interest rates are compounded, and depending on where you go to, they're compounded daily or by the minute or by the week or by the month. The interest accumulates through the period of the cycle for the payments, and then it's added to the amount of the loan, and then you make your payment, and hopefully your payment reduces the total of the loan, the principal, down to be less than what it was before the interest started accumulating again, and then slowly you work it down. Let's take a look at some other things with this payment. What if we did another scenario? I'm going to select everything. I'd like you to select everything in this column, and we'll drag it over by grabbing its border, 2 columns. We'll copy it here, and I'll just make this a separating column. And what if he were to pay down half? Everything else is the same. If you were to pay down half of this loan, so instead of $1,700, it would be $850. It reduced it by quite a bit. And what if the interest rate was changed to, say, half the interest rate? In this case, it would be 9.5%. That reduced it by quite a bit. So we can change the amount paid back by the amount of the actual loan, by the interest rate, and by how long or how many years we have the payback. Well, this concludes the exercise for the introduction to the payment function in Excel.